Hello everyone. This is a series of video on the topic covering the networking, CCNA and the CCNP test. This one is about options or for inter-VLAN routing. This will cover the following topics. Why do we need a VLAN? Options for inter-VLAN routing. How to configure each VLAN and the VLAN routing. And finally, I will do a lab in a Cisco packet tracer. First, let's talk about why do we need VLAN? Because every computer occasionally will have to shout to the whole network, like something like this. Where is the printer? This shouting will create a broadcast storm that slows everyone down. Using VLANs will allow us to create a virtual walls that block unauthorized access between departments. So VLANs allow us to chop up one giant broadcast domain into smaller pieces. Thus, keeps broadcast domain smaller and limit the broadcast storm inside a single group. The first option for doing inter-VLAN is so-called router on a stick, ROS. To illustrate this, I borrowed this picture from this link. So basically, we have switches at layer 2 switches for access. Then on top of this, we have a router, and all the traffics from each VLAN will be routed from the device through the trunk port until this final link between the router and the switch. And this physical line is used for all the VLANs. That's why it's called router on a switch. The router on a switch method must allow us to travel all the VLAN traffics through this trunk link. Therefore, this can be saturated if we have a large amount of traffic. And this structure, router on a switch structure, can only have limited number of VLANs. And in the case when we have a cheap layer 2 switch, we have to use this structure. If we have a layer 3 switch, we can choose another way. So to talk about the method using layer 3 switch, we first talk about layer 3 switch structure. So I borrowed this picture again from another link here. So this block is a layer 3 switch, and each device in different color represent different VLAN, and the traffic from a device is connected as an access port, and then is routed to the routing engine in a layer 3 switch. And this interface is called the SVI interface, which is switch virtual interface. And the link between device and the layer 3 switch is this physical layer 2 interface. Okay, let's talk a little bit about the difference between layer 3 switch and the router. So the key difference are that layer 3 switches prioritize speed via ASIC-based hardware, and this gives us via speed connection. And routers prioritize flexibility and complex features support via CPU-based software, and the routers are slower than the L3 switch. That's why for large amount of devices in a network, we use the layer 3 switch, which is much faster. Okay, there's a concept called switch virtual interface, SVI. SVI is basically a router interface providing IP gateway for devices in that VLAN. It's a virtual logical layer 3 interface for the VLAN. And SVIs make routing inside the switch faster and more efficient without needing external routers. We don't need additionally a separate router if we have the layer 3 switch using SVI. We must enable IP routing command for inter-VLAN routing in this case. I have to say SVI-based inter-VLAN routing on a layer 3 switch is often preferred over the router on a switch, not router on a stick method, because it's faster and efficient. And to demonstrate, illustrate the SVI-based layer 3 switch for inter-VLAN routing, I borrowed this picture from the link here. So the VLAN 10 on this side will be able to talk with another VLAN 20, where this layer 3 switch, the key enabling thing is the internal routing engine here. Every traffic will be connected to this routing, and through this routing we can access another LAN and then switch to the correct port. Finally, the last way, which is a routed port method for doing the inter-VLAN communication, you basically need to convert a physical switch port into a router port. This can be done by running the no switch port command. A routed port can't be shared by multiple ports. It's a strict one port, one subnet boundary. It is used for switch to switch or switch to router links. The key benefits of using this way is that it doesn't run spanning tree protocol, and it recovers from link failure faster than SVI. So this is the end of this session. In the next one, I will do the lab in Cisco Packet Tracer. I will configure VLANs for each switch, and I will do the inter-VLAN with using the SVI on a layer 3 switch. Then I will diagnose and show the status before I run each command, and after each command, compare what happened. This will help you to understand deeper for each command. Thank you for watching. Bye bye.